Hi guys, this is Miss Page again. We are on page 23 of Student Activity 2. Again, we're looking at the TEKS 7.5a and 7.5c, and it asked you to work with a partner to answer these problems. The first problem, parallelogram ABCD is similar to parallelogram EFGH. It asks us to write and solve a proportion to find x, the length of side AD. So, the corresponding sides of similar figures are proportional. AB corresponds to the side EF, and AD corresponds to EH. I'm going to move that up so you can see it. Yay! And then it tells you to write a proportion that compares the ratios of the corresponding sides. So, the small side, or the small parallelogram, AB, corresponds to side EF, the large parallelogram. And then the small parallelogram, AD, side corresponds to the large parallelogram's side EH. And then it asks you to substitute the values into the proportion. If we do that, AB is 3.5 and EF is 7, and then AD is our unknown that we have to figure out, and EH is 4. Use products of means and extremes, or we're going to cross multiply these. So if we do that, we have 7 times x, and then we have 3.5 times 4. 3.5 times 4 gives me 4 times 3.5 is 12, 14, and then 7 times x gives me 7x. Okay, I'm sure I'm doing something weird here. 3, 10. Oh, I understand what I'm supposed to do now. Sorry. Put the 7 right here, and I get 14 is equal to 7x. That makes more sense. Now, if we divide both sides by 7 to find the value of x, we're going to bring this 14 here and this 7x here, and we're going to divide both sides by 7. Move it up. And those cancel, and you get x by itself, and then 14 divided by 7 is 2. So the length of side AD is 2 units. And that is it, folks, for this problem 1. Problem 2, right triangles EFG and MNO are similar. I'm going to redraw EFG so that it is oriented in the same way. So that is the right angle, and that is corner E. I'm going to put F right here, and then G is the one way up here. And that is 4, and that is 1. And I just like looking at them where they're oriented the same way, so I know that this corresponds to this and this corresponds to this. Okay, corresponding sides of similar figures are still the same thing, proportional. Side EF corresponds to side EF corresponds to MN, and EG, this is the reason why I redrew it, y'all, because it makes it so much easier to identify the sides that they correspond to. Okay? Now, write a proportion that compares the ratios of corresponding sides. So the small triangle to the large triangle. If we are doing EF on the large triangle, it corresponds to MN. The side EG on the large triangle corresponds to MO. If we fill in all these good numbers, EF is 1, MN is 2.5, and EG is 4. Now we can figure out what A is. Sorry for doing that whatever you couldn't see, goodness. So if I cross multiply that, I get 1 times A is equal to 2.5 times 4. 4 times 2.5, guys, is 10, and 1A equals 10, and we got to get rid of the 1, which there's not really any need for that, but we're going to do it anyways, and A equals 10. So the length of MO is 10 units. Come back up here and we can label that 10 units. And it makes sense because 1 times 4 is 4, 2.5 times 4 is 10. It works. Problem 3, which rectangle is similar to rectangle BCDE? We got BCDE here, and we've got this one, and we've got this one. So, corresponding angles of of similar figures are congruent. All the angles in a rectangle are right angles. So, both of the other rectangles have angles that are blank to the corresponding angles. They are congruent. So we know that all of the angles are going to be congruent because they're all 90-degree angles. So really what we're dependent on here is which one is the shape that has sides that are proportional to this original one. Okay? The ratio of the lengths of corresponding sides of similar figures form proportions. Match up the corresponding sides of rectangle BCDE and LMNO, and side BC corresponds to side LM. So here's BC, here's LM, BC, LM, and side EB corresponds to side what? Well, there's EB, and that means it would correspond to this side OL. Okay, so we have BC over LM, which if this side is 2.5, then this side is 2.5. So we're going to put 2.5 right there, and EB is 12. Okay, pause it. Now I got to go remember where I was. Write a proportion that compares the ratios of the corresponding sides. If the proportion is true, the product of the means will equal the product of the extremes. Okay, so this BC 9 is 2.5. Okay, now I remember where I was, and put 12 right there. And then we cross multiply those, and 9 times 5 is 45, and 12 times 2.5 is 30, and 30 does not equal, and that's what that means, doesn't equal 45. So this proportion is not true, which means that rectangles BCDE and LMNO are not similar. They're not. I know it's sad. Okay, match up the corresponding sides of rectangle BCDE and STUV. Let's try again. Side BC corresponds to side ST. Okay. And side EB corresponds to the side, well, that means that EB would correspond to the side VS. So, express the lengths of the corresponding sides as ratios. ST would be the same as VU, which is 4.5, and EB is 12. And if I stick these in here, 12, 4.5, and I cross multiply, 9 times 6 is 54, and 12 times 4.5 is 54. They are equal to one another. Oh my goodness, move this up so you can see. So if the proportion is true, rectangles BCDE and STUV are similar! Exclamation point, happy face. That is what we wanted. Okay,